Hi everybody, Patrick here from EngineeringShock.com, electroniclessons.com, and paintballprops.com. This is project number 16 for our multi-project electronics learning board. And this block diagram is very simple. However, the circuit is a bit more complicated. And I'm not going to go through the circuit because all of the tutorials are below. The relative tutorials for this video is your IR sensors. So sensors part 1, which is tutorial 10. Our 74LS93 decade counter tutorial. Our 74LS47 decoder chip, and 7-segment display common anode tutorial. So there's 3 tutorials that you need to know for this, and what we're going to do is we're going to use a TV remote control to count infrared pulses coming from our IR sensor block. Now the IR sensor, there's actually more circuitry here on the IR sensor, but this is just a block diagram. This is our output. When the IR sensor is not being driven, the output is normally high, so 5 volts VCC, and when we drive it using an infrared remote control, the line goes low, pulses low, until you stop, and then it just goes high again. So our counter, our decade counter, which has 4 binary representing outputs, it activates, increments on the falling edge, and our 4 outputs labeled A to D. A has a binary representation of 1, B has 2, C has 4, and D has 8. So in order to enable our decoder and have it so that we can only count from 0 to 9, what we need to do is connect our D, the output is actually labeled out D, worth 8, and out B to the AND pins. It doesn't matter which AND pin. Now, when both of those go high, there's a binary representation of 10 on the line. So what happens is as soon as it goes from 9 to 10, it resets to 0. So you won't actually see what the decoder actually has represented for a 10. It's a weird character. Anyhow, so once we make those connections, every time we get a pulse, it'll send this binary representation to our decoder chip, which is the 74LS47, and this is just a bus on a on the block diagram that drives the 7-segment display. Very detailed tutorials. Go back if you haven't watched them yet. And we've used all of these before many times in our videos. So if you haven't been watching the other videos, you just happen to find this one, look back. Anyhow, so this will count from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and as soon as it hits 10, it resets back to 0. So what we're going to do is once we've hooked all this up on the learning board, we're going to take our remote control. Actually, we're going to take a couple of remote controls because some have a different sensitivity with the specific IR sensor. And we're going to aim the remote at the IR sensor, and we're going to watch this increment. So let's hook it up on our board. The first thing we want to do is enable power to our 7-segment display, and we're going to do that by connecting the jumper here to the EN pins. So now we've got 0 on the counter because the counter is not operational right now because the AND 1 and AND 2 pins haven't been configured. Our IR sensor is right here, and the IR output is on the main pin block in the lower right labeled IR. We're going to take that pin, we're going to connect it to our CLK, or clock input, and now what we're going to do is we're going to connect our AND pins to our out pins of our counter. Now the out pins of the counter are labeled out A tog for a toggle, and that's actually the toggle option is used for other projects. Out B, out C, and out D. So we're going to take the out B and connect it to, say, AND 1, doesn't matter, right here. And we're going to take our out D and connect it to our AND 2 pins. So now what you might notice is this might increment on its own without even pulsing a signal from our remote control. And see, there we go. And that's because it's picking up ambient light. Now your TV, it wouldn't care if it had 1 or 2 ambient pulses like that, because it's programmed to accept certain signals at different pulse widths. Say for channel 1 has a different value than channel 2 button, and the volume up has a different signal than the volume down. Anyhow, what I'm going to do now is I'm going to turn off this light so you can see it better, and I'm going to use this remote from way back here, and I'm going to increment. Now let's use a Rogers remote. I'd like to mention that with my current remote, I can even bounce it off the ceiling, and it'll increment. So I'm just tapping it right now. So if I tap it, I just received 4 or 5 signals. Then 4 more signals just from tapping it. Tapping any button. Now I'm just going to be continually tapping. Now if I use that's my good remote. I can actually aim it at the ceiling. I'm aiming it at the ceiling right now. It's bouncing the IR sensor, or the IR signal is actually bouncing off the ceiling and being received by my sensor. But I'm going to use a Rogers remote now, and I'm going to try the same thing. It's not as good. Why isn't it working? The infrared LEDs on this remote work on a different bandwidth than this specific receiver, or this specific infrared sensor. So only when I point it right at it will it work properly. But it does work properly. It just needs to you just need to be close by. So there you go. So now you can tell your friends that you're able to count the pulses coming out of your remote controller. Now we're only quickly tapping it, remember, and it resets back to 0 once it hits 9 because we have it configured that way. It will pick up ambient signals, but it's not too bad. So, fun little project. Our infrared sensor, normally high output, is connected to our clock input on our 74LS93. The clock increments, or sorry, the counter increments every time there's a negative, a falling edge from our infrared sensor when it's driven. And then our AND pins are connected to our out B and out D pins with a total binary representation of 10, so it resets as soon as the timer receives, or the counter receives the logic of 10. And we've got our 7-segment display decoding properly. So, again, just going to continually have it increment like this. What number will it land on? Who knows? Pretty neat, huh? Okay, so this is project number 16. We got some fun projects coming up, so stay tuned.